Hello everyone, I'm Jonan. Today we're going to be talking about one of the coolest laws in physics, Gauss's law. Gauss's law allows us to find the electric field anywhere around an object, literally. But before we get into Gauss's law, let's take a look at what exactly is an electric field. Okay, so we have this charge here, it's a positive charge, Q, big Q, right? And this Q is going to have an electric field. An electric field is the physical field that surrounds each electric charge and exerts force on all other charges in the field. So what I meant by that is that, okay, let's take a look here with this charge Q, right? We have another charge here, small q. Now if you want to know the magnitude of the electric field right here, that's created by this charge, big Q, that's exerting on the small q. How are we going to calculate the magnitude of the electric field? The magnitude of the electric field is denoted by E, big E. It's a vector, right? Because that's the direction on where it goes. So the intensity of the electric field is calculated by K, which is the Coulomb's constant, 8.99 times 10 to the 9 Newton meter squared over Coulomb squared, times Q, the charge here, the charge that's gonna exert the electric field, over R squared. R is the distance between the two charges. So now we know that the E field exerted by big Q on the small q right here, on this position right here, is kq over r squared. Now an easy way to recognize the direction of the E field is that it's the same direction as the electric force exerted on a positive charge. So we know that these are two positive charges, right? And two positive charges, they repel each other. So that means that the electric force is going to be in this direction, in the same direction as the E field. Now what if it's a negative charge? Now if we have another charge, now it's a negative charge, what's the direction of the E field exerted from this charge? The E field exerted from this charge, the direction of the E field exerted from this charge is going to be the same as the electric force that this charge exerts on a positive charge. So let's have this hypothetical charge here, Q2. So the direction of the E field is going to be the same as FQ. So FQ2, FQ is going to be in this direction. So the E field is going to have the same direction as the force. So the direction of the E field, there's going to be a E field coming in all directions, in every single direction, right? And since this is a negative charge, the direction of the E field is going to be towards the negative charge. And for this one, it's a positive charge. The direction of the E field is going to be outwards from the charge. It's going to be outward, right? So that's the E field from all directions. And as you can see from the formula, the distance is squared. Therefore, the further the distance, the weaker the E field is going to be. So it's going to be weaker and weaker as the distance increases. And this goes the same for all directions. Note that any charge or any charged object creates an electric field around itself, and that, people, is it.